Welcome to section 2.9, lecture 10. Alright, so we're going to be looking at combining like terms when you have a variable in an expression. Alright, so at the moment we're just going to be focusing on expressions, not equations. So our first problem. Suppose you bring 3 musubi and 1 soda to a picnic, and Keahi brings 2 musubi, 6 pork hash, and 1 soda to the picnic. How many of each item are at the picnic? Well, let's go ahead and figure out what different types there are. Well, we have 3 musubi, and then 2 more musubi. Let me go ahead and write this down. So we have 3 musubi and 2 musubi. What else do we have? We have 1 soda and another soda. So 1 soda and 1 soda. And then what else do we have? And 6 pork hash. Alright, so 6 pork hash. So how many of each item are at the picnic? Well, that means we have, I kind of ran out of room here. We have 5 musubi total, because we added up the 2 and the 3 musubi. Then we have 2 sodas. And we still just have 6 pork hash. So we didn't combine any of the numbers for pork hash, but we did combine the musubi together and the soda together. Okay, because the musubis were like terms and the sodas were like terms. Alright, so for B, give an algebraic representation of these items. State which each variable represents. Okay, so we need to go ahead and introduce algebra here, which means we need to create variables. So let's see, what would be a good variable for musubi? How about m for musubi? So let m equal number of, let me change the color here. I'm going to go ahead and use yellow, as that's what I was using originally for musubi. So m equal number, m equal the musubis. And then what else do we have? We have soda, so let's go ahead and use S for soda. I normally don't like using S because S oftentimes tends to start looking like a 5, so I tend to try to steer away from that, but it'll work. And then why not P for pork hash? Alright, so for my problem, we have 5 musubi. And in algebra is plus, so 5 musubi and 2 sodas and 6 pork hash. Well, I'm going to go ahead and replace or introduce my variables to the problem. So pork hash is supposed to be P, so we're going to go ahead and swap that out with P. And then sodas, we're going to take that out and replace it with S. And finally, musubis, we're going to go ahead and take that out and replace it with M. So my algebraic expression is going to be 5m plus 2s plus 6p. So there we go. That's an algebraic representation of our problem. Alright, example 2, we're going to simplify by combining like terms. Alright, what are like terms? Well, example, just like in part A, it's the terms that are alike. For example, if we were saying how many sodas are there, you wouldn't go, okay, well, there is 1 soda, and then I'll go ahead and take that 2 from musubi, so we have 3 sodas. That doesn't make sense. Musubis and sodas, you cannot combine them. They're not like terms. When we're counting them up, we don't combine them. But we do combine the 2 from musubi with the 3 from musubi to get 5 musubi. So you have to make sure they have the same term attached to each number. So let's go ahead and look at A. We have 3 A's, 4 A's, and 1 more A. Well, if you're thinking about that in terms of apples, as everyone loves to hear, what would that be? 3 apples plus 4 more apples, that's 7, plus 1 more apple is 8 apples. 8A. Real quick, a note on this. When you just see a variable by itself, it's shorthand for 1a. If you don't see a number in front of the a, it is that 1. Okay. All right. Go ahead, take a second, see if you can identify the like terms in part B. Well, I have 3m here and a negative 2m here. And then 4xy and 5xy. That's a positive 5xy and a positive 4. Well, that means we have, I'm going to go ahead and group them, 3m minus 2m plus, and then we have the 4xy, plus the 5xy. So adding up the like terms, this is going to equal, well, 3m minus 2m. So you had 3 musubis, you ate 2 of them, how many you have left? 1 musubi. Plus, and I'm going to go ahead and keep with blue here. So you have 4xy's and 5xy's. So you had, let's say you had $4 and you added $5, you have $9 total. So 9xy's. And there we go. Alright, pause the video and try C by yourself and check in with me. Okay, let's go ahead and identify the like terms. Well, we have a 2ba squared. There's a 4ab, but the a doesn't have a square, so that's not going to be a like term. We have to find another a squared. Here we go. 3ba squared. There we go. And then let's see, we have a negative 4ab. Do we have any other ab's? Right there, the 3. Okay, so let's write out our problem. I'm going to go ahead and draw that in. So we have 2ba squareds plus 3 more ba squareds. And then what else do we have? Negative 4ab plus 3ab. All right, combining like terms. This is going to equal, well, we have 2 plus 3. That's going to be 5ba squareds. Plus, let's see, negative 4 plus 3ab's. That's going to be negative 1ab. You could write the 1 in front if you want to. Most of us don't. Let's go ahead and simplify the final answer. Drop the parentheses. And there we go. And once again, these are not like terms because of the a squared. Okay, the a squared makes these two not like terms. Okay, make sure to watch out for the parentheses. Watch out for the exponents. All right, so moving on. The distributive property. So when you hear the word distribute, what do you think of? You're giving things away, right? That's what you think of when you're distributing. For example, if we had this guy here, let's say this is the teacher, right? So the teacher might have test papers in her hand, right? And then these are the students sitting at their desks. If the teacher wanted to distribute the papers, she gives 1 to this student, 1 to this student, and 1 to this student. That's the distributing. Each student gets a test. Well, so a similar concept will apply to distributing with algebra. The thing we have to identify is what's being distributed. So, you see this 2 outside the parentheses? I'm going to write it a little bigger. Right in between, there is a multiplication going on. So, you use the distributive property when you're having multiplication. And if you see the distributive property up above, what happens here with that multiplication is you'll take the a value and you'll distribute it to each of the terms inside the parentheses. So if you have 2 terms inside the parentheses, you'll distribute twice. If you had 3 terms, you'll distribute thrice. If you have 4 terms, you'll distribute 4 rice? I don't know how to say that. Alright, anyways. So, let's go ahead and solve, or distribute. Alright, so I see that 2 here is multiplied, so I'll go ahead and distribute that to each term. Remember, thinking of that concept of the teacher handing out tests. So then we're going to have 2 times 3 plus the 2 times 2n. So you might say, why are we multiplying? But remember, it was 2 being multiplied. So we have to multiply 2 to each of them. So then it's going to be 2 times 3, it's 6, plus 2 times 2n, 4n. And there we go. Alright, so looking at b, how many times will we have to end up distributing, and what are we distributing? Well, this whole outer piece here is what's being multiplied to the parentheses. So we're going to have to distribute that entire negative 4a, and we're going to distribute it 3 times to each of these terms. And remember, terms are what are separated by a plus or minus sign. So let's go ahead and write this out. So that's negative 4a times 4b plus negative 4a times 2a. Ooh, we're running out of space here. Plus negative 4a plus 3b. Oh, I definitely ran out of space there. I wonder if I can switch things on this. Let me go ahead and rewrite this because I'm running out of space for my other problem. Okay, let's do it again. So it's the negative 4a times the 4b plus the negative 4a times the 2a. Notice I use tons of parentheses, and you might be wondering why. Well, whenever I start playing around with negatives, I always use parentheses, because if I don't use parentheses, there's a high chance I will forget a negative somewhere, and then I'm in trouble. Alright, so multiplying this out, for negative 4a times negative 4a times 4b is going to be negative 16ab. Bringing down the plus sign. So that was that. And then negative 4a times 2a is going to be negative 8a squared, because there are 2 a's. Bring down that plus sign. Let's see. Negative 4a times 3b. So that's going to be a negative 4 times 3, 12ab. Alright, let's see. What do we have left? Well, negative 16ab plus, actually, that's going to be a minus a squared minus 12ab. Now, last thing to do is check, do we have any like terms? Well, I have a wrong one. I have an ab here, negative 16ab. Ooh, and a negative 12ab. Those two are like terms. So we can go ahead and combine those. That's going to be negative 6, 7, 8, 28ab minus 8a squared. Okay, go ahead and see if you can distribute for number or part C. Alright, so what are we distributing? Well, we're distributing the half. And we're just distributing it twice. And remember, that's a negative 4 over 5, so please remember to include that negative. Let's see, we have 1/2 times 2/3 n plus 1/2 times 4/5. Let's see if we can do some canceling here. Those 2's cancel in the multiplication. So for that, I'm left with 1 times 1 over 1 times 3, so 3n. Plus, let's see, anything cancels here. Well, 2 can go into itself once, and 2 can go into 4 twice. Alright, multiplying across, 1 times 2 is just going to be 2. 1 times 5 is going to be 5. Are there any like terms there? Well, we have an n, and the other one does not have a variable. So, that's it. No more like terms. Fractions are a bit complicated, but just take your time, and you'll do fine. Okay, for some reason I have example 4 is the exact same example as the one we did previously. So we're going to go ahead and cross this out because we've already done this example. Another thing, I'll have to change on my notes. They are unending. Okay. Example 5. Identify the greatest common factor and write it out in factored form. Okay, so I'm going to do a real quick example. Let's say you have 3 friends. And they all want to hang out together. And they all want to pay their own way. But they have to decide what they can do with how much each one has. So let's say this is Keahi. He has $5. And let's say that this is Tim. He has $10. And let's say this is Kayla. And she has $7 in total. So what would that be? A $5 and a $2? And $2 bills do exist. I have 2 with me at home. Alright. So, let's say they want to go, well, they can go either to bowling, which is $5, or they can go movies, which is $10, or they could go eat at some spot for $6. And remember, they each want to pay their own way. So what activity can they all do? Take a moment, think about which activity they can all do if they want to pay their own way. Well, for bowling, let's see. It's only $5, and they all have enough money to go bowling, so that's something they can do. How about movies? That's $10. Keahi can't go to the movies, and neither can Kayla, so that's not going to work. Let's see. Eating out is $6. Well, Keahi can't eat out, Tim can eat out, and Kayla could eat out. But remember, all 3 of them want to go along. So the only option they have is bowling, which would be $5. So $5 is the greatest common factor that they all have. They all have $5. Okay? So that's the concept we're going for. We want to see if we can find something they all have in common. So let me go ahead and erase this from my screen. Let's see if we can apply this to some math. Okay. So first off, note, sometimes it helps if you factor each term first. And what does it mean by factoring? Well, for example, if you have the number 15, you could factor 15 into 3 and 5. If you had the number 4x squared, you could factor this into 2 times 2 times x times x. So some examples of factoring. So let's go ahead and factor a out. Let's see. Well, 5x, that's just 5 times x. How about 25? 25 is 5 times 5 times y. And 10k is 2 times 5 times k. Alright, so take a moment and think. What is a factor they all have in common? Well, they all have 1 5. Do they all have an x? No, they don't all have an x. How about, do they all have 2 5s? No, they don't all have 2 5s. Okay, so all they have in common is they each have 1 5. So that 1 5 is going to be our greatest common factor. So our GCF for this problem is 5. And let's go ahead and factor out that 5. So I'm going to rewrite the problem. So when I factor out 5, I'm going to write the 5 out front. Basically, this is the exact opposite. Oh my goodness, what am I doing? Figuring this out. Okay. Factoring is the exact opposite of distributing. So pretty much it's going to look exactly like how it looked before you would have distributed. So we got the parentheses and that multiplication. So if I take a 5 out from 5x, what's left? Well, just the x is left over. So I'm going to go ahead and write in that x. So it's just x left over. And then, if I decide to factor out the 5 from this group, what's left over? Just the 5y. That's the wrong color. So the 5y is just left over. And for the last term, if I factor out a 5, what's left over? The 2 and the k are left over. So we'll just go ahead and write what's left over, which is the 2 and the k. And there we go. We have found the greatest common factor and factored it out as well. And then we write the remainder on the bottom. So how could we check if we had factored this correctly? Well, we could just re-multiply this back out using the distributive property, and see whatever we get, is it what we originally started with? Let's do that. 5 times x is 5x. 5 times 5y is 25y. And 5 times 2k is 10k. Is that what we had originally? Yes, it is. That's a horrible looking yes, yes. All right, awesome. So that's a way you can check. We're not going to do that for all of our problems, but if you ever feel like checking on your homework or on your exam, you just use the distributive property to check your factoring. Oh, I sort of just messed it up. Oh, let me rewrite that. 5 times x plus 5y plus 2k, and we box our answer beautifully. All right, next one. Go ahead, factor b, and check back in with me in a second. Pause the video. All right, so factoring this, it's just 3 times a times k. Oh, x, sorry. 6a factors into 2 times 3 times a. And 9a factors into 3 times a times a. Okay, so what do they all have in common? Let's see. They all have, well, he has a 3. He has a 3. And he has a 3. Careful, we're not going to include both 3s because these two guys do not have 2 3s. So we're just going to take 1 3. Let's see. Well, he has 1a. This one also has an a. And this one also has an a. Let's see. This one has an x, but this one doesn't have an x. And that one doesn't have an x. Alrighty, that's it. So just 3a is our GCF, our greatest common factor. And I'm going to go ahead and identify that. My GCF is 3a. So that is what I will be factoring out. So factoring out 3a, I'll leave my parentheses. Let's see, when I take out 3a, I just have x left. Plus, factoring out 3a, I just have 2 left. And then for the last term, factoring out 3a, I just have another 3a left. And there we go, we're done. Once again, you could multiply this out to check if you factored correctly. All right, last one. Once again, our first step, unless you can see it in your head, which if you can do it in your head, it's fine. It's always good to go ahead and factor completely. So that's 2 times x, and this factors into 3 times x times y. All right, take a second, pause the video, see if you can identify the GCF. Well, this one has an x, and that one has an x. In fact, they each have 2 x's. But they don't share anything else in common, so our greatest common factor is going to be x times x, which we can actually simplify into x squared. So factoring out x squared, what do we have left? Just the 2 from the first term, bring down the plus sign, and then just the 3 and the y from the second term, 3y. And there we go. We have successfully factored the last problem for this. And that is it for this section. Please email me if you have any questions or need help with the homework assignments.